Okay, in part 3 here, we'll finish up by starting with a discussion on this idea of a harvestable surplus. This is a really important concept and has to do with our two types of mortality. Your book does a good job of giving some examples, so let's see if we can just nail down this idea. So first of all, we have additive mortality. Additive mortality means that you have all of these different causes of mortality that add up to take out a certain number of individuals in the population. So here's some of your causes over here: disease, accidents, exposure like cold, starvation, predation, harvest, which would be like hunting. And so in this first example here of an unhunted group, we have 100 individuals dying per year. So that's our mortality, 100. And all of those causes increase the total mortality in a population. So if I add in hunting to that same population, if I hunted them, I would increase my total mortality to 125 because it's an additive cause in this case where all the other causes of mortality still occurred, but in addition to those causes, I lost another 25 individuals that year to hunting. So that can happen. We can have additive mortality, but we can also have compensatory mortality. And now I want you to go back to this first group here where I had 100 individuals dying per year and look at how many were dying to predation, how many were dying to exposure, and how many were dying to disease. And I look at this population B. Let's say this is the same population, but this time I am able to hunt, it looks like, about 40 animals out of that population, but my total mortality for the year didn't change. How can that be? Well, it's that way because my other causes of mortality actually went down. I had less animals die to predation. I had fewer animals die from exposure, fewer animals die from disease, but my harvest took out some animals, so my total mortality didn't change from what it was here when I didn't hunt. So in this case, hunting or harvesting is compensatory, or it's compensating for some of these other causes of mortality. So that's really common in like our upland game birds, where we know that we're only going to maybe retain 20% of the population for recruitment the following year. And it doesn't matter if we go out and we shoot 60% or 40%. If we shoot 40%, another 20% is going to die anyway. If we didn't shoot any, 60% was going to die because of a hard winter or not enough food or getting eaten by predators, all those other reasons that tend to play a role in those prey species populations. So we just compensated for other causes of mortality through hunting. And that's a pretty commonly used management strategy. If we can figure out what our mortality is for a year and decide, well, if we hunt some, does that just mean we have fewer animals dying to other causes, or are we going to add mortality to that overall population? So looking back here at compensatory mortality, think about it in that word. They compensate for each other. The different factors do. So the total mortality in a given period of time does not increase. So does a harvestable surplus, this idea of a harvestable surplus, occur with additive mortality or compensatory mortality? I'm going to leave that up to you. I'll post a question here so that you can answer it. So what are the arguments against relying on a harvestable surplus? Why might we not want to bank on there being a surplus of animals that we could harvest? Well, that gets a little controversial, right? If we are assuming that we're going to only lose 60% of the population to natural mortality factors, but a year comes around where it's a harsh winter, or we have some kind of density independent factor come in that we weren't expecting, we could lose more. And if we banked on there being a surplus available to harvest, kind of those that were going to die anyway kind of attitude, then we could end up having a much higher, it could turn into an additive mortality much more quickly, and we could have a much higher rate than we originally intended. A couple final thoughts with terminology. You'll hear production and yield. Production refers to the biomass accumulated by a population at a certain time period. And with biomass, again, we're typically referring to fisheries management when we're talking about the pounds of fish that we have in a lake or a stream. Once in a while, we can refer to biomass with wildlife, especially when we're talking about grazing animals, because we can have those AUMs. Remember, that stands for Animal Unit Month. And an animal unit is a way of kind of standardizing the effects of grazing from different species. It's how much that rangeland can support. And so in that situation, you might be referring to biomass. Yield is the portion of the population taken by humans. So that's that harvest level, or yield can be the same thing. Maximum sustained yield, that is how much can we take from a population without endangering future reproduction and recruitment. This is a hard line to find. Sometimes after a while we get these pretty ingrained, and without any major changes in habitat or recruitment, then we kind of have our levels figured out. This is important because things like fishing licenses and hunting licenses, if we can maximize our take out of these populations, we can sell more tags. And as we've talked about and learned about so far, it's the hunting and fishing that pays the bills for a lot of our wildlife management in each state. And so we want to try to maximize what we can take out. But if we overtake, then we can be hurting those future generations of those species. We use this idea of maximum sustained yield often in fisheries, and we're going to try and manage those populations in ways that produce the most production. How can we get big fish faster? Okay. Optimum sustained yield then is a management philosophy with an objectives that consider ecological and socioeconomic factors. So remember when I mentioned about this carrying capacity idea that we have this level, let me see if I can draw here. We have a carrying capacity level where it levels out, whoa, maybe right in here, and my wavy line seems to work well since I said it was never quite flat. This might be the biological carrying capacity of a population, but it might not be the social carrying capacity. The social carrying capacity might be way lower. Maybe we could support this many wolves in an environment, but maybe humans are only accepting this level. So here's the idea that humans can then influence what our carrying capacity is by some socioeconomic factors. How do we then balance the biological or the ecological amount with the socioeconomic amount that we can support? And that might refer to where our carrying capacity is, and it might refer to where our yield happens. How much are we willing to take out of the population? Science may say one thing, and people may say, I'm not comfortable with that. I need it to be less. Or there might be pressure actually for it to be more. And so we need to try and manage a couple of different philosophies there. So an idea here, and let me see if I can erase my drawing. All right, nice, I can. For example, we could have fewer tags that might produce bigger, better quality bulls, or we could sell more tags for bulls, and there be fewer in the population because we're taking more out, and so we might have to be satisfied with taking out smaller bulls because we haven't kind of laid off the hunting pressure and allowed there to become some big trophy elk. So how many we're willing to take out of a population should be based on science, but you cannot forget that social factor as well. Ecological factors affected. I think we've kind of talked about that, and we've talked about this. So I think that wraps it up. This is a really good quote for this lesson. Nothing is more characteristic of living systems than change. That is the one thing that you can be certain of, is that things will change. Your populations will change. The dynamics of those populations will change for certain. And you just have to keep on top of how is it going to change and what can you do about it. So good luck. Being a wildlife manager is not easy.